Hello, everyone. This is Hannah Kramer with Lawrence Berkeley National Lab, and we'll get started in a minute or two as people are joining. Thank you. All right, I think we'll get started. Thank you for joining us. I'd like to welcome you all to the Scaling Up Fault Detection in a Portfolio. This is a webinar that's a part of the Energy Management and Information Systems Better Buildings technical team. And so we're pleased to have you here today. Next slide, please. Our guest speaker today is Gary Mullaney. We're very happy to have Gary talk with us about all that Kaiser Permanente is doing, which they have been doing for many years with respect to implementing fault detection across their portfolio. So Gary is a senior energy consultant at Kaiser Permanente, which is an integrated healthcare system where he supports affordability and environmental stewardship goals. He works on a wide range of projects in energy and water management, from distributed energy resource deployments to efficiency and conservation efforts across the country. Prior to joining Kaiser, Gary served on active duty in the U.S. Army, where he deployed multiple times in support of combat and security operations. Gary has a degree in mechanical engineering from the United States Military Academy and an MBA from University of California, Berkeley. He also is a certified energy manager, a certified climate change professional, and is married and the proud father of 2 little girls. So you would think he looks more tired than he does. A few quick logistics here before we get started. Please type your questions throughout this webinar into the Q&A, and we'll try to get to everyone's questions. We'll reserve plenty of time for questions at the end. We always get the question of, will we get slides after the webinar? Yes, there's some really great slides in here with lots of detail, so you'll probably want to take a look at those. Along with the recording will be sent to you after the webinar. All right, next slide. I'm going to just set the stage for Gary's presentation with a very quick look at the history of fault detection and diagnostics for commercial HVAC systems. So first, just a reminder that fault detection and diagnostic tools are a subset of a larger category of tools called energy management and information systems. So fault detection focuses mainly on automatically analyzing building automation system, control system data for problems and also opportunities to improve operations. So both the problem side and the improving efficiency side. So this kind of software, Lawrence Berkeley National Lab has been working with vendors and partners and doing research for many years in this area. And we're pleased that we see it becoming really an essential tool for building engineers to have the view they need into system operations to run their systems efficiently. So prior to about 2000, fault detection and diagnostics was mainly in the research realm. There were only five commercialized tools available in the market. And some of these tools you might not even call fault detection today because they weren't as automated as they are today. If you're interested in that very old report, that was my master's thesis in my master's program. So way back when. By 2020, I've been on the LB&L team where we've documented 50 different EMIS with FDD capabilities. So it's been a real explosion in the number of software vendors that have this capability out of an overall group of over 100 EMIS products, which have a broader look at energy meter data and so forth. Just a sort of point of reference, though, the Smart Energy Analytics campaign We ran that from 2016 to 2020, and we collected data from over 100 portfolios across the country, and we reported out on cost-benefit information. 40 different software tools were implemented by these over 100 portfolios. So it's really getting to be a little bit more business as usual. We wouldn't call it quite yet business as usual, but we're seeing larger deployments of FDD as vendors streamline how they implement the software and connect with the control system data. And also as owners are sharing their experiences and, showing the benefits they're getting. So Kaiser Permanente is just a great example of this scaling process with almost 20 million square feet of building floor area with FDD, which is a really incredible feat and has had a lot of hard work to get there by that whole team there at Kaiser, and especially by Gary. So we can learn a lot from how they've made it happen. So without further ado, I will hand it off to Gary Mullaney from Kaiser Permanente to share with us their story there.
All right, thanks, Hannah. Appreciate it, and looking forward to talking to everybody today and sharing what we've done. Hopefully, I can let you know what's gone well and what our challenges have been. So, next slide, please. All right, next slide. So first, just for those that are not familiar, Kaiser Permanente, large integrated healthcare system. So it consists of the Kaiser Health Plan and the hospital, as well as our medical group. So fully integrated system, serve almost 13 million, 12.5 million members, and pretty large footprint, 70 million square feet of occupied space across 8 states plus DC. So from the East Coast to the West Coast and all the way out to Hawaii as well. So, and we're talking, we have hospitals, we have medical office buildings, and I feel like everything in between. So a lot of different facilities makes it really interesting. So next slide. So to just figure, if we're talking about scope, I should start with, or scaling, we should start with where are we right now. So right now we are at scale. We've got 18 million square feet, about 189 buildings in all of our regions. So like I said, from Hawaii to Mid-Atlantic, all up and down the West Coast, and here in Georgia where I reside. But we still got a lot more. We've got 7.3 million in the pipeline, and there's more and more going. So we're kind of at scale while still scaling at the same time. So it does make things challenging, and it's been quite often it's kind of building by building. So it's definitely a bit of a process, but let me walk through kind of how we got here, and then I'll talk about kind of how we're able to do it. So next slide. So kind of what the journey started with, and I'll admit I did not start at the very beginning. I really started pretty much around that decision point in 2017. So I don't have as deep a knowledge on all of the details of how we got here, but I got a pretty good background on it. So early on in 2014, we had some regional buildings down in Southern California that tend to always be a place where they like to try to pilot things, and there always are folks on the leading edge trying to do new things. And they don't have hospitals and medical office buildings, so I think they've got a little bit more room to take some risk. So they went ahead and tried some fault detection and diagnostics, and they seemed to get some value. And I think that got a little bit of buzz and some interest. It got picked up at a national level, and they decided to do this as a competitive RFP. So they pulled in 15 vendors, which based on what Hannah put out there, probably at the time was a large portion of what was out in the market. So pretty wide swath. We selected Clockworks Analytics, and we awarded them an MSA. So it was back in 2014, 2015, we did some national pilots. So that was 3 medical centers, one in Southern California, one up in Oregon, and then one in Colorado was a medical office building. So pretty good swath of buildings, different types of buildings, and in different climates. So we wanted to get a good sense of it. And we really picked some of our best performing facilities. And even at those facilities, the FDD was able to identify 2.5 times the investment. So pretty good opportunity. And a lot of those sites right off the bat were able to get some really great savings and implement a lot of those measures. So it wasn't just they were identified and there are things we couldn't do anything about. Those sites all had really strong results. So that was the pilot. And then it really brought us to kind of the decision to scale. Are we going to do this or we're not going to do this? And a lot of that came to The first thing we tried to do is actually, we decided we were going to try to scale, and went and tried to do a national business case. And I actually was on board when that business case was getting developed, and I tried to help pull it together. However, it didn't go anywhere. Unfortunately, we weren't able to get a big central pot of money funding to roll this out across the enterprise, even though that was what the original plan was. But that didn't stop us. So next slide. We still decided to scale the program. We just had to go at it a little different approach. One of the tools that ended up being really effective, and I'll talk a little bit about it later, is we actually integrated this FTD requirement into our capital program. So this became a requirement, and it's actually, it's kind of evolved over time. So it's even more advanced now, but at that time it was just, hey, if you met any of our new buildings, so if we're doing a ground up new construction site, or if you hit, I think it was 250,000 in control spend, the way our chief design engineer saw it is, hey, this is going to pay for itself easily in just being able to make sure that we get our money's worth with those new controllers, make sure we get the most out of those systems. And it's a drop in the bucket for a capital project versus rolling it out as an OpEx spend. So that really did help us. It wasn't the only thing we did. We did still got a lot of sites to sign up using their OpEx dollars, but this kind of shows you what the journey was. Kind of by 2018, we were at 64 buildings in 5 regions. By 2020, though, we had hit 120. It's almost doubled that, and we had hit all 8 of our regions, and all the way up to now, where we're at about 170. And it's that number's, I feel, flexible because we're always bringing on new buildings. I feel like every week. And along the way, we did pick up some awards. One of the early ones that was successful was our Zion Medical Center. It was actually one of our pilots in Southern California. They won the American Society of Healthcare Engineering Energy to Care Champion Award. So only one selected each year. And they actually were able to really leverage the FDD tool as part of, they were doing an infrastructure project as well. And they actually ended up being a set of eyes for the operations team on the project, because the project actually caused some issues, and that FDD was able to find those issues and get them resolved right away, as opposed to just having to deal with them after construction was done or years later. So it really ended up being, that kind of helped inform some of this idea of putting it in our capital program, making it part of that, part of our commissioning as well. And then we did pick up a DOE Smart Energy Award, so that was pretty nice to pick that up and get that recognition. But continuing to move along. So next slide. Let's talk a little bit about kind of how did we do that. That was the journey. So I think first and foremost, it starts with communicating the value proposition repetitively. Since this wasn't like I had a bucket of money to go do this, and even if you do get it deployed, if you get deployed through a capital project, you ultimately need to get the FAC Ops team to be on board with it, because at the end of the day, they're the ones that are going to continue us and roll into that monitoring-based commissioning years 2, 3, 4, and beyond. So kind of sort of turned into this internal salesman. Never thought I was going to be a sales guy, but I feel like that's what I ended up doing, because I had to constantly be pushing the program and helping people understand what the value was. We also spent a lot of time trying to highlight the success stories, especially from those pilots. So we took their words, took their feedback, and shared that back out. It certainly is more powerful when they hear from peers. So if a chief engineer is hearing from a peer, than if they're hearing from some guy at national, which is what I was. And then we did our best to quantify the impact, and that's one of the values of FDD. It really does help easily quantify the work that a lot of this work people are doing, but a lot of engineers don't have time to go and do they either don't know how to do it, or even if they do know how to do it, they don't have time to do the energy calcs to say, hey, this is saving us X dollars of money, X dollars by making this fix. So I think that really helped, that ability to put a dollar on fixing these issues, especially on the energy side. We established some site selection criteria. So we tried to focus our efforts, not just pick up every single building, but really tried to focus on larger buildings where we'd have the best opportunities. And then also looked at kind of the timing and where people were in their journey, if they are kind of diving in and getting into the energy management and kind of starting down the process. This was the natural kind of next step in maturing their ability, especially if they had made those investments and trying to make some measures. I saw this doing FDD as allowing them to continue it and to make sure that they didn't backslide after the fact, because we see that kind of feel like I always see this energy and water management. We make investments, we take 2 steps forward, and then we take 1 step back. So I feel like this is sort of that insurance policy to make sure you're constantly moving forward, or at least not falling back. And then establishing the funding mechanism. So that was OpEx and CapEx, and I'll talk a little bit more about that later. Next slide. So we're talking value proposition. It's all about the building controls and overrides, and that's always an issue with our sites, and I see it in the data frequently. So jump to the next slide. So this is from our internal kind of dashboarding tool. We use Tableau, and it's just a rolling 12-month energy profile. And so this is one of our sites, and we noticed this trend. It kept going up when and this was a case where we actually looked at it in retrospect. And so I reached out to the team and to be like, what happened? That's a pretty significant bump. That's a 50% increase in gas usage. And it turns out that there was a lot of turnover in the local engineering team, and they really lost sight of their building controls. So things were getting overridden. They had just stuff had been undone, and the building was just really, it was out of control from a HVAC standpoint. And so this is actually a building where we had earlier had clockworks in place, had FTD in place, and then they had pulled it off. There was a lot of turnover. Now we're getting it back in there, and I think it's going to really help them. And this is one of those cases where, and I can point to these in many of our buildings where we constantly see that step back. And quite often when you see a spike in energy, it's tied to some change in the BMS. It's almost always operational. Next slide, please. So that's where we see using things like our fault detection and diagnostic work can really help in this. And more than the tool, it's also the process, really focusing on monitoring-based commissioning. The entire idea of monitoring-based commissioning is to prevent you from doing that cyclical, oh, I'm going to do a retro commissioning every 5 years. So really want to avoid that. We want to just constantly be moving forward, or at least not moving backwards at a bare minimum. So these dashboards really allow you to quickly see it. You can quantify what the impact is, and it can really provide focus. And if someone sees this, they can also communicate to the manager, hey, I need to go do this work, and they can quantify why it's more important than something else that they're going to do. They may not always win that, but they can at least make the case for why they need to spend a little bit of time on this, which is otherwise can be hard to do. Next slide. So another value proposition that's outside of the energy world is, and this is pretty low hanging, is sensors. And I found this on the internet as just a good example of just how many sensors are getting packed in to really all of our buildings. In healthcare, we have a ton of sensors just keep getting packed in there, but there's not really a plan for how to maintain those sensors. They're obviously they're run to failure, but then you're really just waiting for the impact. So someone calls and says they have a comfort issue, something's not working, and then you have to find out what happened. Whereas, next slide, with FTD, this kind of stuff is very easily, and here's an example of, I think this was our Zion facility where they were able to, this shows where they initially found the issue, they fixed it, and they could see the fix in the data. And then I think it was maybe 4.5 years later, they saw it break again, and they were able to go in and fix it. But we could actually monitor the entire life cycle of a sensor in the FDD and allow us to actually kind of get ahead of things. Next slide. This just gets into, there's dashboards you can pull up and just quickly see what are all the sensor issues you're seeing, because otherwise, like, where else can you quickly see all your sensor issues? And then you can go through and prioritize them as well. So next slide. Yeah, and there's multiple ways to look at it. You can get it from a dashboard. In this case, it's just a quick search. They were able to pull it up, and you can see those sensor issues. Some of them also have a cost component, so that can help you really prioritize your efforts as well. Next slide. So the third area, and this is an area where I'm still pushing to get better adopted, mostly because we don't always do a great job in energy management at the local level. But this comes from Energy Star, and this is, I know there's a dozen different ways to to capture how do you do energy management. It all generally has a similar look and feel. But having gone through this at several of our sites without fault detection and diagnostics or really any other analytics, I saw how painful it was and how kind of slow the process was and deliberate it was. And I saw the more time I spent using smart building analytics, things like FDD, I saw how it could really accelerate this effort and make you work a lot smarter, both internally and if you bring in someone external. Because quite often our building management system, I would see the case of we'd go out there, we'd create a plan, and then they'd go to quantify these measures, and they'd have to go set up a trend, and then they'd have to get that data back after 2 weeks. And it ended up involving a lot more people, and the trends might not be set up, and they'd have to wait for it. And then, hey, did we get a good trend, or did we miss the season? So when you have this FDD with all this historical data in there, it's just a treasure trove. And you give that to a smart commissioning agent or an energy man or somebody, or like an energy auditor, they're gonna have a field day with it, and it's gonna accelerate their efforts. And they can spend less time bugging your teams to get this data pulled or set up these trends. So next slide. And there's so many different ways they can look at it. I just gave a couple screenshots of some different reports that we have. One of them up here, this commissioning bill of health, is something we use in our commissioning program. So we actually make our commissioning agents have to have the building pass what we call a clean bill of health. So we use our FDD on all of these buildings, and before they can turn that building over, they need to show that they've got really it down to, it doesn't have to be zero, but they got basically energy faults are down to zero, and the comfort and maintenance faults, or faults that have a comfort and maintenance impact, need to be down to a really minimal level before they turn over. The idea is that you wouldn't go and buy a car and drive off the lot and have all the check engine lights on. This is kind of the same idea, but we don't always have that for buildings. And commissioning quite often is pretty static. So this allows it to be more dynamic, and it's a third-party look. So you can't cheat the system or play around and say, hey, everything was in control at this day. Let's send them that snapshot and everything looked good. But then the next day things went out of control. Next slide. So here's a couple testimonials. So I'll just highlight. So down at our Modesto, this is one of our pilot sites. They found a bunch of savings before they even completely turned over the tool. So this was during the pilot, and just showing a quick comparison of like really along every metric you can look at, they were saving significant amount of money. Their Energy Star score went way up. Their source and site UI were reduced significantly. And the part I always like to with this is he really understood the fact that this kept him from slipping backwards. He knew if he got rid of this, unless he had his guys just constantly staring at the BMS all day and had every little thing, they were going to miss something, and something was going to start backsliding. So they knew this. You kind of always saw it as an insurance policy. It could sometimes make it hard to sell it to your leadership because they want to see those savings all the time. But I think this is a case where he really understood it. Next slide. This is another engineer, and what they saw, they didn't see as much energy savings because this building was already LEED Gold. It was pretty new building, so there wasn't as much energy savings for them to find. But what they really enjoyed was they used it and they got ahead of comfort calls, which is huge. It's not gonna save you money, but it's gonna improve occupant. And we're talking about healthcare facilities. So if you can make their stay just slightly better, that's worth so much. I know it's hard to quantify, but it's still really valuable. So this was a case. It's a really hard thing for us to measure. We haven't been able to measure it effectively, but I've seen other anecdotes like this where we can just, and I think it helps. If an engineer can go out and take care of something and get less comfort calls, that's really going to help morale as well with your team. Next slide. So then impact. So we looked at impact a lot of different ways, and I won't go through the painful detail, but I look at, because our buildings weren't deployed, we didn't deploy this in like multiple big phases. We had to I had to be creative in how I looked at the impact, because you got to look at when they deploy and give them. My goal is that a building's up and running for 2 years, and by the time it's been running for 2 years, that it's captured enough savings through completed tasks. So they've identified issues, addressed those issues, captured that savings, and documented it to cover their first year cost. And that first year cost includes implementation cost and the first year of the subscription. And I figure if they can do that in 2 years, then they are more than good on covering their savings, as long as they are continuing to stay engaged along the way. But and we're pretty close. We've got a lot of buildings that have this list in the top left is by campus. So these are all buildings that have easily covered their cost. And then on the bottom, this is kind of the all time. So there's still some facilities that I need to work on engagement, but 94% is pretty good. And we're almost 80% for a year and a half. This one on the bottom right is another one where it's not energy. And again, we've always struggled with how to best quantify things that aren't energy costs. But this is a good case where this was a facility, and they had pretty high. This is what their scores were. They had like a comfort. It was the average. It was like the value of their fault. So each fault has a comfort, energy, or maintenance. And so they're on here, and you can see the big drop in particularly maintenance and comfort. And so they took a 3-week period and they called it a blitz. They blitzed the facility with a couple of extra engineers, and they just tried to address as many of the issues they saw in the FDD as possible and really focus on it for a few weeks. They had to take care of other things, but they really tried to kind of surge some support of the facility, and they saw the impact here. Comfort and maintenance immediately came down. They had some energy savings as well. There was a little bit more of a lag before the energy savings came, but immediately they were able to address a lot of comfort and maintenance issues. And realistically, when I look at the sheer number of faults that come in, the vast majority of the faults have a comfort and maintenance impact, not an energy. Energy is a subset. There are ways you can find additional energy savings that don't show up directly in the faults, but the comfort and maintenance really is the majority. So I've been trying to mature the program to start looking away from just energy, because as I'm looking at other folks that have been doing this, I see that as the natural progression of your maturity to really see the value of the program is if you can see it beyond just energy. Next slide. All right, so site selection. So for our targeted buildings, we try to target all of our medical center campuses. So if you're building on a medical center, we try to get all of those buildings that have conditioned space. And then any of our campuses are kind of over 100,000 square foot. That's our targeted, because that's where we're gonna get the most bang for our buck. However, I do see that we have a lot of smaller buildings as well. And in some cases, there are some that will make the argument that those smaller buildings can be just as valuable, because those buildings might not have an engineer there all the time. So now you have a set of analytics running 24/7 on a facility. And so that when you do have to send somebody out there, you can actually send them out because you know something's gone wrong, or you can get them before you get a call. You can actually send them out because the analytics are informing when they go, or when they do go, you can at least send them, and they can be armed with all of this analytics so they can make the best use of their time. When we've got some facilities that are, as we try to spread out our footprint, there's times where we have MOBs that are in more isolated locations, and it doesn't make sense to have an engineer there all the time. So we target those bigger buildings, but I do see value in the smaller buildings as well, depending on what the strategy is that team is following. On the capital side, on the funding side, we have had a lot that have been funded through capital projects. That really has been helpful, and just especially those first costs. We know local teams sometimes really have a hard time swallowing the pill, especially if you're talking a whole medical center, of putting that upfront money. They just don't have a lot of room in their budget. But capital, it's usually pretty easy to get that deployed. But we have still had success in the OpEx side as well. It just depends on the facility. And one thing we've done is we actually have done some like split funding, where our large regions, like in the Californias, they'll have some regional initiative dollars, and we're able to we get them to fund the onboarding cost, and then the local cost agrees to pay the subscription cost. So it's a way to kind of get over that initial hump. So that's one thing that worked effectively for us. Next slide. Oh, and I should actually last slide, back one, please. This bulletin, that's just that's the bulletin that went out that kind of highlighted that FDD was required for all of these. It wasn't just FDD. We had everybody go to Clockworks just to make things simpler. We have enough BMSs already in the enterprise. We didn't want to do the same thing with FDD. So we want to centralize on one system because it made life a lot easier. Was it things like that clean bill of health would be a lot more difficult to do if you had to do that in multiple different FDD platforms. So having one really made things a lot simpler. Next slide. This is kind of our operating model. This sort of the mission statement I try to follow with Kaiser Permanente employees and partners. And I note the partners because quite a bit of our commissioning agents, external folks, we're not bashful. We don't try to hide the data. Hey, if you want to engage and you want to help us save energy, improve the performance of our facilities, we'll let anybody get in there and use it as long as they're obviously they've got a purpose to be in there. So we make it, which has really been valuable because those partners often have a really hard time getting a hold of this data. It always has to be downloaded and exported. It can take weeks. Now it's just, hey, give them access and give them a little short tutorial and they're off to the races. Fully engaged, that's really a key part. And then leveraging FDD and continuous commissioning process, it really is those two things together. I try to, sometimes you get focused on the technology, the FDD part. I try to always remind our teams that the technology is great, but unless you got the process paired with it and that continuous process, you're not gonna see the value. The tool doesn't do anything by itself. It does great in analytics, but it doesn't save you energy or improve your facility by itself. You need that process. We have had a decentralized approach, not basically by choice, but just by the way we operate. So I just like to highlight that because that's the reality we face. In some cases, some of our regions are starting to not do full centralization, but they might have like a BMS team that covers their whole region. And so then it's a kind of a partnered effort where that BMS team are often the experts in FDD and they're using it to do anything that's on the BMS side. And then they're working in partnership with the local teams that might be focusing more on the maintenance issues, the things that require hands-on. So that decentralized approach is important because it does make things more challenging. It does make the scaling, it's harder to scale a decentralized approach than a centralized approach. Use cases we talked about, and monitor-based commissioning, capital commissioning are really our two primary, but we're constantly looking at other use cases. Right now, I'm trying to, I just had a good work group this week on how can we use this more for maintenance. So things like that sensor maintenance or even other areas. So we're getting ready to explore, put a couple pilots together at 2 of our facilities to really start trying to quantify how we can use FDD to really drive maintenance and improved operations. This little kind of formula on the bottom is what I kind of early on when I put this, was trying to put a little bit more structure around this program and starting to scale it. This was kind of the framework that kept coming up to me. Was this is kind of the success formula is what I call it. It's also, you can think of it as these are kind of the levers you can pull. So everybody wants impact, they want savings, they want something quantified, but how do you get that? So you can bring more buildings on board. That's going to increase the kind of the size of the pie. You can drive more analytics, but really analytics hasn't been the challenge. Sometimes it's a matter of the more we dive in, we can find other uses for the analytics, other ways to look at it. I've never ceased to be amazed by what you can learn from that data when you start diving in. But the most important one is that engagement. And that's can be the most challenging one. But that's where I try to drive people, say, hey, you want impact, as long as they've got a decent deployment. If they've got like one small medical office building and they're like, hey, why are you not showing me a lot of savings? I was like, well, it's not a large building and it may not have that many issues. Usually it's, hey, if they've got the whole medical center deployed, they've got a good size scope, it's probably engagement is why they're not seeing impact. And then I can usually look and see, well, nobody's been logging in, or it's been very hit or miss whether anyone's logging in. And once you talk to that leadership, then they like, oh, okay. Then they go and they start pulling that lever harder, and then voila, they start seeing some impact. This last one I'll talk through is just, this is kind of how I see the process and how I try to communicate it to our teams. So there's certain pieces of the process that kind of Clockworks is doing, the FDD tool, it's doing the monitoring. You don't have to sit there and monitor, it's monitoring the equipment. It's kind of automating the identifying and quantifying the faults and opportunities. And it provides you the tools to allow you to prioritize. But then that's where the Kaiser person or external partner has to jump in, and they need to start looking at it, choosing what their priorities are based on what they've been directed. Are they doing maintenance? Are they doing energy? They got to jump in there. They got to look at it. Sometimes they get overwhelmed with the size of it. I just remind them, you got to take it a little piece at a time. And then they got to go out, fix the fault or action the opportunities. And then this last step, which I think is really critical that sometimes gets missed, is they need to come back and actually verify that the issue's been fixed, which I know is often hard for them to do. But when you have FDD, that's another one of the superpowers is you can see that right away. Hey, I went and fixed this. Is the fault still showing up? You check the next day. Oh, wait, the fault isn't there. Or you check in a week. Oh, wait, we fixed it, but then it popped right back up in a week. Okay, that turns out that whatever I did didn't actually fix the root cause. And so you kind of go back through the process. Next slide. All right, so a lot of what I do, not so much training. I do the training at a high level, mostly for training the managers and training the leadership so they can understand what are the metrics they should be looking at, how do they need to drive engagement. I'm not teaching them how to use the tool per se. I let the Clockworks team do the technical training. I do a lot more of the governance. And so what I've been doing is we have this enterprise-wide work group. It's really me, the Clockworks team, and then anybody who has a login to the FDT tool. Anyone who has a login, they are all invited to these monthly meetings. We do training, we do updates, we do collaboration, we get them to provide feedback. We also have a team MS Teams group where we can share all the documentation. So it's a place to share best practices and kind of sometimes just trying to motivate the group. I'll share these kind of metrics. We put a program handbook together that just kind of documents all of the processes, especially with scaling. Having good documentation, having good processes. What I started realizing, I was having the exact same conversation with all of our PMs, and we have something like, I think we have like 200 capital PMs across our enterprise. We have a pretty large capital program. I was like, I don't have time to have this same conversation with 200 of them. So I started documenting that stuff into a handbook. And so when they reach out to me, I could just kind of send them that, and with a couple quick words of saying, hey, take a look here, look in chapter whatever, and that usually could answer their questions, including things like FAQs. So kind of it can be tiresome. It can be a lot easier to just kind of run in, but I think putting that together really helped us with scaling. Monthly regional meetings. This is one thing that we've been doing, and actually I'll talk a little bit about. We have these monthly calls for the enterprise, but really where the work gets done is when we can do that at a more regional or even a medical center level, because that allows us to provide more tailored support, tailored training. They tend to speak up a little bit more when it's just folks they know versus sometimes I think some get intimidated on a big national call, even though I think it's a pretty safe environment. And the final thing was this performance dashboard. And this is something I started doing a couple of years ago, was trying to understand kind of, we all want impact, was how do I what are the right metrics to show? And I kind of see these as, these are leading indicators. So one of them we looked at was kind of what's the average weekly logins. And so we'd look at that at a monthly basis, and we'd look at the last 3 months and kind of what the trend was. We'd look at task creation. So I think work order creation. And then we'd, from an energy standpoint, any of those tasks that had energy impact, we'd look at what the annual avoided cost was of those. And then we'd look at the same thing for the task completion. So that's kind of the natural flow. You log into the system. So step one, we need to get them into the system. And it may sound silly, but sometimes that is a challenge, just getting consistent engagement, consistent login. then they need to be creating tasks. That means they're actually looking at the diagnostics and doing something about them. And then finally, kind of the more on the lagging side is you've got to actually go out, fix the issue, and then you've got to complete the work. So this dashboard to me just made sense to kind of walk through. And then when I could talk with leadership, this is how I could use it to say, who did I need to reach out to? Like, oh, I see that their engagement's down a bit. I don't understand what's happening. I'm not seeing any impact. So let me reach out to that team and try to have a conversation and see what's going on there. And sometimes it's, hey, there's been some turnover. We've lost some guys. We need to do some more training, do some kind of push some more engagement. Or my biggest concern is always trying to avoid what I say, suffering in silence. That was early on. We had one site that we lost. They're actually one of our original pilots because there was a mix-up, and the original person who was the champion for that site left to another for another region, and he never really got backfilled. And then there was just kind of a drop in communication. And this happened as I was joining the team. I realized like nobody has logged in that region in months. I was like, that's not a good sign. I reached out, and it turns out they had been chasing their tail over some bad data, but they didn't tell anybody. So nobody could fix the issue or address or help them provide some training. So I'm now kind of hypersensitive to making sure we don't have anybody kind of suffering in silence, so that we can help them out and get them the training they need. They've got the supports available, but sometimes the engineers are I know, apprehensive to ask for help. Next slide. Yeah, I think I talked a lot about this already, training and governance. So we do training at initial turnover. We do there's support requests are built in. There's a new portal with this is kind of a dashboarding tool, which I think is really powerful. This is an example. A lot of the dashboards you've seen in here come from their new dashboarding tool, which I think is really helping from a governance standpoint. And the way I see it is I really want our teams to see the Clockworks team as kind of an extension of their team from an advisory and technical standpoint. So if they're in there and they're working through a fault, if they're having an issue, I want them to be able to quickly feel like they can reach out and get the support. The guys on the other end have a lot of technical support, technical knowledge in this kind of stuff. They know the analytics inside and out. I know our guys don't necessarily know, especially early on. So that's kind of what we try to kind of preach from a training standpoint. Next slide. All right, so I think I've probably hit on some of these lessons learned along the way, but let me just, I'll hit them kind of in summary. So focusing on the engagement metrics is really important. I tried to used to focus on the impact, but realized focusing on the impact is just, you can't move the needle on impact unless you're driving engagement. So I really shifted my thinking on that and really focused on that with our teams. I think getting creative on the funding deployment really helped. So if a team is interested, but they maybe not have the funding available, figuring out if there's a capital project where we could piggyback on, or if there's some regional funding that they might be able to get. I think that has really helped us being creative in that sense. Try to widen the use cases and value proposition. I think if you get into this just for energy, that might be a place to start, but I think you need to go in thinking more broadly than that and really think about all the different use cases and value propositions that you can bring to bear, because energy is the easiest to quantify, but at some point, even if you get a building fully tuned in, there's just sometimes people have a hard time seeing that you're not getting more savings, but it's at a certain point, you probably get to the point where you can't get any more kind of low hanging fruit. So you've got to look at those other places where you can add value. One other thing I'll say is the right sizing of the service support. We just actually signed a new MSA, and with that, I increased the level of service to really support at scale. We tried to have it at a regional level, and I realized we needed support at a more medical center level. So we increased our service level, and I think that was important. Some teams, if you really get going and you have a centralized, you might not need as much service. We needed a little bit more. Yeah, next slide. I know we're probably up on time, so I can pause if you want, but these are just some of the things we're thinking about. A lot of it's continuing. I think the biggest thing we're still working on that I haven't already talked about is integration. So right now we're trying to integrate with our CMMS. So that's the goal for this year. And then also with our internal, our Tableau, our internal dashboarding tool, if we can pull in some of this data into that, I think it's going to be really helpful. So those are the two of my focuses on the integration. I think all the other items I've kind of already talked about. So I think that's my last slide, Hannah.
Great, excellent. Thanks, Gary. Well, we have a lot of questions. People are very engaged. That's great. I just have one quick reminder from the Better Buildings and Department of Energy side of things that while Gary has, explained his particular experience with one particular vendor software, we are vendor neutral and we're not promoting any particular FDD product. And in fact, there are lots of FDD products out there, as I mentioned at the beginning. So just that little disclaimer there, although it is nice to get sort of the real live explanation of how it's going for one organization. Okay, so I've organized the questions as they've come in into kind of process questions and technical questions. So I'm going to start with maybe a few technical questions here. So are you monitoring other equipment outside of your HVAC equipment?
Not generally, and that's mostly just a limit to our BMS. Our building management systems we're working on getting them to be in a better place, but quite often we don't have a lot of extra stuff tied into the BMS. We're just not at that point yet. So there's a whole other team that I work closely with that is trying to really, I see that as the infrastructure. And so we have an entire BMS strategy that to some degree, in some ways, we are a little bit ahead of ourselves in some ways. So, but I think now we're trying to push the two programs along at the same time. So.
Great. Here's a question on how do you calculate the cost savings for the faults, and that's through the tool. But maybe you could talk a little bit about what that's based on and how you feel those calculations kind of reflect reality.
Yeah, so they use, I probably am going to do a poor job trying to explain it as well as the Clockworks team could do, but I know it includes weather-based data. They're using real data that obviously the trending data, they've got access to all that building management system data. And then in addition, they've collected system size data. So they know the size of the fan speed. So, and then they're just doing basic energy calculations. And I know there's some regression analysis that goes into it, but I've had our internal design engineers take a look at it that are also energy engineers. And they, if anything, they always say it's pretty conservative. So I feel pretty comfortable. And the other question I'll have is, you could get it. Are the savings actually persisting? And we actually did a pretty interesting study. So one of the guys went through all of the completed tasks, and there were some cases where we probably needed to provide some training and they got closed too early. But the ones that were closed, they went through and they validated that the issue was fixed. And then in most cases, those persisted for multiple years, and many of them were still persisting at the time. So, because that was another question that commonly came up around cost savings are, well, how long is it? Is this really, is an annual savings a fair number? And I think absolutely the numbers, when we did our own internal persistence study, it absolutely showed that annual was still that's realistically a really conservative number.
That ongoing persistence piece is really key, because once you have that savings, then you may have to remind people that savings is something you need to maintain. Okay, so here's a question about have you found that having more sensors in your building control system that's integrated into your FDD versus having a simple BAS, do you get more value out of the FDD when you have more sensors versus, let's say, if you have a pneumatic system? And sort of as a related question, do you have to add more sensors sometimes to make the FDD implementation more effective?
Okay, I'll try that best. So I don't really have a specific study I can point to, but I've just generally when I look at our buildings, the ones that still have a lot of pneumatics are the worst performing from an energy standpoint. So absolutely go to DDC, go to digital controls. But I don't have like a specific, that's anecdote, just looking at our data. When we deploy our FDD tool, we have not been adding additional sensors. Occasionally that has come up and the team can tell you, hey, here's some places where you could add some additional ones, but there's no push for that. We just, so there are limits. You are limited to the BMS data available. And I think you could add some. We haven't got to that point yet. It's part of the, there's so many things I could do in our program. I have to prioritize, and it can be tough because we're still trying to grow the program. So adding new buildings, still trying to onboard the buildings, and still trying to make sure the ones we have are being fully engaged and exploring new opportunities. So, and I feel like I have all this other stuff I do as well. So I feel like this could be my full-time job, and that kind of stuff would be definitely something I'd be interested in look into. Are there some key places where we can add some additional sensors, which would add a lot of value, but we just haven't got there yet.
So if you don't have sensors like meters on equipment, for instance, then you just don't worry about it for now, and you use them if you have them, basically.
Yeah, for the most part. And there's some kind of virtual metering you can do when you have this data in the BMS. So in some cases, honestly, a lot of times we put meters in and then we don't tie them into our BMS, or there's not. So we don't have a great history with sub meters, unfortunately, at Kaiser. But where we do have them, if they're tied into the BMS, then absolutely they get pulled into our FDD.
Yeah. We hear the same thing, by the way, from lots of other organizations, that they're using the data they have, and there's plenty of data. So there's plenty to find.
Yes.
Okay. How do you overcome challenges with onboarding older facilities? And do you have, I guess as a related question, do you have a need to do the controls upgrade first? Do you have sort of a process where you might require that first?
So that's a good question. That actually is a challenge we've had at times. We've had some real integration challenges. We've never had a site that we haven't been able to integrate. But I've actually kind of told our team that's looking for new sites to start doing some better investigating on the front end to make sure that we don't bite off something that's going to be really hard, because we've had some sites that have just taken a really long time to get fully integrated because their BMS is just a mess. An older system, or it's kind of a Frankenstein system. We usually just keep pushing through and trudging through, and we've got a BMS. I've got kind of a counterpart on the BMS side, and he's really valuable in pulling in and helping us figure things out. So we've never failed, but there's definitely been cases where it's taken a lot longer. So but quite often we are bringing our FDD in after the BMS has been upgraded. As I said, like a lot of these capital projects they're coming in and they're doing an HVAC project that includes a BMS upgrade. So that's a great time to bring it in right after it. So I think if your BMS is in really rough shape, you should fix your infrastructure first before you start kind of putting all the bells and whistles on top. So that would be my advice.
Great. Okay, so we're going to switch over to process questions now. There's a lot of interest in your team structure and how that all works for you as you scale. So does each building engineer have access to the FDD system, or someone filtering issues to them? So I guess it's that question of the project champion and how do they work with their staff at the site?
We generally give access pretty widely. Now, who's actually logging in? That depends site by site. I see the sites that have more of a team approach generally do better. Early on, we did push kind of the FDD champion approach, and I've really tried to move away from that and really try to preach the team approach. Because what I would find is sometimes it would be successful. If you just had a dynamic champion, they might be able to do the front end work and then go out and actually go fix these things, especially if there were a lot of BMS things. And it might be literally shifting from I'm on my FDD, now I jump over to my BMS and they go and make some fixes. And so it can be done that way, or they have to go out in the field and actually make some fixes. But really what I see is ideally you have at least 1 to 2 people that can do that front end integrating. They're investigating the issues they're seeing in the FDD. And then they've got support from a chief engineer or assistant chief, somebody who has kind of that tasking authority. And then they're creating work orders, and that's why we want to get the integration with their CMMS, and then they can push out to the whole team, especially those kind of non-BMS issues. So if someone has to go check a stuck damper, we don't need that person who is a BMS expert to go out and do that stuff. Let's have somebody else give them some specific instructions and send them out to go do that. That's kind of my vision for it. We're not there by any means, but I think with the CMMS integration, that's going to really help.
Great. Okay, I think we have time for maybe 2 very quick questions. How small of facilities do you implement FDD? I know you mentioned you sometimes get small when you don't have an on-site engineer.
Well, a lot of times the small ones are either one of 2 things. Either they get deployed as part of capital projects, and in that case, there's value in putting it on there. And then the question just comes, it's more of a marginal cost. Once you've got it deployed and you've got it implemented and it's being used for commissioning, it can still be valuable even if it's a small building. I'd say usually not much smaller than like maybe 30 to 60 is probably most of our medical office buildings are kind of probably in that sweet spot. And then we have the bigger ones, but that's probably a lot of them. And so we have deployed to a lot of those buildings. In other regions, they just tried to deploy to everything because they just wanted to have a full picture of all their buildings. They didn't want to kind of cherry pick. They want to just have that full picture. So then when a manager could look, they could actually see all their buildings on there. So it just depends on the strategy. I just don't, if I'm going to focus my time, I focus on the larger buildings. I'm just trying to get all of, at a bare minimum, I'm trying to get all our medical centers online. And that's a struggle because we still have some that are pneumatic. So.
Okay, so 30 to 60,000 square feet is about that range of those smaller ones, sounds like. Yeah. Okay, so I don't think we have much time for more questions, but there are a few more, and we will see if we can kind of respond to some of them around utility rebates and maybe how the team kind of is structured from an organizational perspective in the recording and slide deck. So thank you so much, Gary. I'm going to move now towards our wrap up here. We have these Better Building Solution Center resources. All these links are live when you get the deck emailed to you. Please reach out to me if you have questions. If you want to join the Better Building Tech team, follow these instructions. Next slide, please. We also wanted to put a shout out for an interesting opportunity with NYSERDA with a RTEM hackathon. So real-time energy management is RTEM is the acronym that they use for their EMIS program. It's an incentive program managed by NYSERDA. They've had a lot of success in New York. So they have this treasure trove of data, and they are putting it out there in anonymized format for 200 buildings. And they want to see if people can find new ways to use this data that can positively impact electrification or decarbonization of buildings. So they have prizes. And in any case, this is for those folks that really want to just hack into some data. And here is a data source, a really big data source. It's even normalized and tagged using Project Haystack and BRIC standards. So next slide, please. I will also mention that DOE has launched the Better Climate Challenge. It's pretty exciting that there's over 100, actually almost 100 owners and partners that have signed on board to reduce their scope 1 and scope 2 emissions by 50% within 10 years. So that's the minimum pledge for signing up. And there's still time to sign up in this first kind of wave of signups. And just last week, the Secretary of Energy, Jennifer Granholm, and the National Climate Advisor, Gina McCarthy, presented and sort of kicked off the whole thing. So it's up and running. LBNL's involved in the technical assistance portion, and it's a pretty exciting program. Next slide, please. And then finally, last but not least, is the summit. So many of you know about the Better Building Summit. It's back live in person this year in DC. And this is our time to come together and have owners talk with owners, have the Department of Energy support and facilitate discussions. So It'll be the first conference I've been to in a couple of years, so I'm excited to go. And if you're interested, here's the link to learn more. So thank you so much for attending. We had a great attendance, and thank you again to Gary Mullaney from Kaiser Permanente for his expertise and time. Have a great day.